Hi, and welcome to FAILUROLOGY, a podcast about engineering failures. I'm your host, Nicole, and I'm from Calgary, Alberta. I was notified last week that FAILUROLOGY is the number 4 physics podcast in Canada over the last 30 days. This is amazing news, and I want to thank each and every one of you for downloading and listening to FAILUROLOGY each week. I am beyond grateful for your support. I hope you all enjoyed the FAILUROLOGY origin story episode last week. It was a lot of fun to make. I haven't made a video recording like that before, and even with just that one, I've already learned a lot, so I hope to make more in the future. I even started making little videos of mechanical systems for the LinkedIn page of the company I work for. On that note, I've added my LinkedIn to the show notes if you want to connect with me. I recorded the origin story video a week before I released it, during the Family Day long weekend here in Alberta. And then I spent a good portion of that week second-guessing posting it, because being vulnerable is really scary. But in the end, I just had to go for it. And also, I wanted to give myself a good week off to relax. I love making this podcast, and I love my job. But I am very aware that burnout is real, and I had been spending the majority of my free time working on the podcast, which again, I love doing. But a little break was just what I needed. And I'm back, rejuvenated, and ready to bring you more engineering failures. Just a reminder to all of you out there, especially if you're working from home and your work and home life have started to blend together, not only is it okay, but it's also required to take a break. This week's episode is the Sunshine Skyway Bridge in Tampa Bay, Florida. I love bridges, almost as much as I love tunnels. There's this one bridge in Chatham, Ontario that has an open Great Deck, and it used to make a noise when we drove over it. As a really small child, I affectionately named it the Noisy Bridge. And every time we went to Chatham, I asked if we were going to cross the Noisy Bridge. And admittedly, I would get really upset if we weren't going to cross it. I also called convertibles cars with no lids. It was such a simple time back then. When I started the podcast, I set some ground rules for what failures would qualify for each episode. The rules were pretty simple. The accident needs to be a failure that resulted due to shortfalls in the engineering design. But this week's failure doesn't quite follow that rule. But since I make the rules, I can break them, right? The Sunshine Skyway Bridge collapse wasn't due to a design flaw. It was hit by a ship during some really bad weather. But the collapse led to design changes to future bridges to prevent this from happening again. So while previous episodes have been an engineering flaw that resulted in failures, this episode is a failure that resulted in engineering changes. But I still think this story is important. It demonstrates how failures impact and shape future designs. While the failure was not necessarily caused by design shortcomings, the bridge collapse directly resulted in a change to the new bridge design to prevent something like this from happening again. And like the Sampoong department store collapse, when I heard about the Sunshine Skyway Bridge, I immediately looked it up and read the entire Wikipedia article. I even bought a book on the bridge, called Skyway, The True Story of Tampa Bay's Signature Bridge and the Man Who Brought It Down, by Bill DeYoung. And then when I was watching the Super Bowl recently, Go Kansas City, which took place in Tampa, I was reminded of the bridge and immediately looked it up again, as if history had changed since the last time I read about it. You know, it's funny. I've seen many Batman movies, some of them multiple times. And every time I see that scene with Bruce and his parents in the alley, I think, even if for a brief moment, maybe they won't die this time. Alas, time travel is not yet possible and we can't rewrite history, but we can definitely learn from it. So without further ado, let's get to the news. This week in engineering news, the NASA Perseverance Rover touched down on Mars on February 18th after launching on July 30th of 2020. The rover touched down near an ancient river delta looking for signs of ancient life and collecting rock samples to bring back to Earth. The 2012 Curiosity rover, who was roaming just over 3,000 kilometers away from where the Perseverance landed, caught stop-motion video of the last 2 minutes of Perseverance's descent. The Perseverance rover had 25 cameras and 2 microphones. most of which were on and transmitting images, video, and sound to NASA during the 7-minute plunge through Martian atmosphere. And Perseverance is the 5th NASA rover to be placed on Mars. Since 1962, humans from 4 space agencies have been trying to land robots on Mars to study it. There have only been 9 successful landings, including this most recent one. What makes this landing so special is that Perseverance, for the first time ever, is a round-trip journey. The rover has 43 sample tubes designed to be filled with rocks, dirt, and air for eventual examination back on Earth. While we've been able to see these samples for the last few decades, this is the first time they'll be brought back to Earth for testing. If you want to read more about the Mars rover Perseverance, check out the link in the show notes or head to FAILUROLOGY.ca. Now on to this week's engineering failure, the Sunshine Skyway Bridge collapse. The bridge replaced a ferry from Point Pinellas at the southeast tip of St. Petersburg to Piney Point just north of Port Manatee in central Florida. The bridge is almost 9,000 meters long. For scale comparison, the Brooklyn Bridge in New York City is just over 1,000 meters long, and the Golden Gate Bridge in San Francisco is just under 3,000 meters long. The original bridge was a cantilever bridge, similar to the Quebec Bridge that I covered in episode 6. The Sunshine Skyway spanned the shipping channel in and out of the port of Tampa. The majority of the bridge was a few meters above the water surface, but where it crossed the shipping channel, it rose up to 46 meters above the water. So it looks like the bridge has a hump in the middle of it. At the time, it was the most massive application of pre-stressed concrete for an American bridge. The original span opened on September 6, 1954, as a 2-lane bridge built by the Virginia Bridge Company. A similar span was built in 1969, parallel and to the west of the original span. The opening was delayed due to reinforcing work on the South Main Pier, which was cracked due to insufficient supporting pile depth, and it ended up opening in 1974. The original span was used for northbound traffic, and the 1974 span was used for southbound traffic. The bridge was subject to 2 major maritime disasters. In January 1980, a U.S. Coast Guard cutter, Blackthorn, collided with the tanker Capricorn near the bridge. The cutter sank and 23 crew died. And of course, the star of the episode, on May 9, 1980, the freighter MV Summit Venture collided with a bridge support during sudden bad weather and collapsed a portion of the southbound span, killing 35 people when their vehicles plunged into the Tampa Bay. Due to the complexity of the shipping channel in and out of Tampa, a harbor pilot maneuvers the ship through dangerous and congested waters. Their number one priority here? Don't hit the bridge. The pilots were stationed at Edgemont Key outside the bay to meet incoming ships or depart outgoing ones. In 1975, a law was passed that changed the hiring process for new pilots. It used to be done by the pilots themselves, but now it was done by Florida's Professional Board of Regulation. The pilot who ran into the bridge, John Lero, was the first pilot under this new hiring practice. The original pilots felt that he was forced on them, and they weren't a really big fan. On the day of the collision, a storm came up suddenly and caused torrential rain, 110 km/h winds, and dense fog. This reduced visibility to near zero and rendered the freighter's radar useless. When John Lero, the 37-year-old harbor pilot, was steering the ship through the shipping channel, he realized that they had veered out of the channel. He put the engines into full reverse and dropped the anchor, but the ship still hit support piers of the bridge. The MV Summit Venture was 185 meters long and 25 meters wide. It was made in a Japanese shipyard and was flying a Liberian flag. At 7:33 a.m. on May 9, 1980, the freighter MV Summit Venture collided with a support column. The main pier at the passage under the bridge through the channel withstood the ship's contact without much damage. But a secondary pier, which was not designed to withstand impact, failed catastrophically, and 370 meters of the southbound span collapsed into Tampa Bay. 6 cars, a truck, and a Greyhound bus fell 46 meters into the water, and 35 people died. Sidebar story time. I mentioned in the Flint episode that I grew up outside of Windsor, Ontario. Being at the southern tip of the Ontario Peninsula, surrounded by the Great Lakes, we got some interesting weather coming off the lakes. I definitely still see some weird weather in Calgary, especially with the Chinooks, but that's another story for another time. Anyways, we saw a lot of fog in Windsor, like a lot of fog. So much so that we used to have fog days where the school buses didn't run in the morning, but they'd run in the afternoon after the fog had lifted. So I know what it's like to drive down the road, windows down so you can hear, trying to see what's in front of you, but there's so much fog that you can't see much in front of the car. There was one fog day that was especially bad, and it's always stuck with me. It was September 3rd, 1999. The Windsor Airport Observation Station failed to detect foggy conditions, and at around 8 a.m. near the Manning Road overpass, one semi entered very dense fog and slowed down, causing the one behind him to jackknife. Visibility was about 1 meter. A chain reaction of crashes resulted in an 87 vehicle pileup. A lot of people were injured in their vehicles as cars kept crashing into the pile. Some were even trapped, and some were injured trying to escape. 8 people died that day, and 45 people were injured. Improvements have since been made to the 401 to try to prevent accidents like this one from happening again. But I'm telling you this story because imagine you're driving around and you can only see 1 meter in front of you. You're probably questioning why you left the house that morning, or maybe you have an important deadline and you're trying to make it to work safely. You're driving along and then all of a sudden, there's no road, or in the case of the Sunshine Skyway, no bridge, and you fall 46 meters into the water below. 46 meters is a long, long way down, and breaking the surface tension of water is not forgiving. I believe the majority of those that drove off the Skyway Bridge died on impact, and those that didn't drowned. I can't even imagine how terrifying their last few seconds were. The collapsed section was on the descent of the hump over the channel, and the drivers had no idea that that section of bridge was missing. There's a toll booth at the start of the bridge, and they were eventually contacted, but by the time they stopped traffic, there were already several people driving across. Dick Hornbuckle and his 3 passengers were driving across. They noticed the bridge was out, and Dick slammed on the brakes, stopping 35 centimeters from the abyss. They were the first vehicle to stop before driving off, and they helped prevent others from driving off into the abyss. There's a picture on the podcast webpage of the yellow car teetering on the edge. That was Hornbuckle's car. Wesley McIntyre's truck flew off the bridge into the side of the freighter before rolling into the water. He was the only person who drove off the bridge and survived. Luckily, many other drivers, thanks to Dick Hornbuckle and his passengers, were able to stop their vehicles before they reached the gap. The Florida Department of Transportation realized it needed to improve the crossing to prevent this from happening again. Even with harbor pilots and protected main piers, there was still a risk of collapse. The southbound span was used as a fishing pier, and the northbound span was eventually converted into 2-way traffic until a new bridge was built. Before the original spans were demolished, McIntyre was the last one to drive over it. The original bridge was demolished in 1993, and the approaches were made into the Skyway Fishing Pier State Park. The south approach, sitting 800 meters south and west of the current bridge, is still there today, and the north approach was demolished in 2008. With the disassembly of the original bridges, there were some engineering challenges. All underwater piers and piles, surface roadway, girders, and beams had to be dismantled. Some pieces became part of artificial reefs in the new state fishing park. They also had to focus on the order of disassembly. They needed a safe method for detonating charges on concrete and steel members in a publicly open and difficult to control area. They also had to safely remove in one piece the bridge's main span and concrete piers so they didn't block the shipping channel. Using a pulley system and several winches, the 110-meter, 608-ton span was lowered onto a barge 46 meters below. Real-time computerized, synchronized descent calculators and control programs were used to ensure all winches lowered at the same rate of 9.1 meters per minute. The disassembly of the span over the shipping channel was completed in 2.5 hours, despite adverse weather conditions. While today this might seem like an easy system to develop, for 1993 this was pretty impressive. Now onto the new bridge. It was determined that rebuilding the original spans would not improve shipping conditions, and they also looked at a tunnel, but it was impractical due to the high water table. So a new bridge was built, and it opened in the middle of 1988. When they were building the new bridge, they had a few things to look at. The main reasons for collision were human error, mechanical failure, environmental conditions, and alignment of the bridge with respect to the entrance channel. There were practical protective measures suggested. Design the piers and pier shafts along each length for ship impact, raise the roadway along the entire crossing, protect main and flanking piers with sand-filled rock islands or dolphins, and shift the main span of the new bridge so that it was more perpendicular to the shipping channel and reduce the impact of the offset of the channel. The new bridge was cable-stayed, so there were 2 towers, each centered on the main piers across the channel, that cable spanned from to the bridge deck. Only the channel crossing is cable-stayed. The rest of the bridge is supported by closely spaced piers. The main span across the channel is 50% wider than that of the original bridge. And the piers for the main span and the approaches for 500 meters in either direction are surrounded by concrete barriers, called dolphins, to protect the piers from collisions by ships. There are 36 dolphins in total. 4 large ones protect the 2 main piers, supporting the cable-stayed main span, and 32 smaller ones protect the bridge piers for 500 meters to either side of the main span. Previously, the approaches would have only been designed for live and dead loads, but not ship impacts, which is why when the MV Summit Venture hit the main pier as well as one of the approach piers, the bridge collapsed. Had that ship only hit the main pier, the bridge would not have collapsed because that main pier was constructed to withstand ship impacts. The bridge piers can withstand an impact of an 87,000-ton ship. It's constructed of 300 precast concrete segments linked together with high-temp steel cables to form the roadway. They exploited the elasticity of pre-stressed concrete to absorb and transfer impact loads. And it's protected along the entire length, from shore to shore, not just at the shipping channel. As if navigating the shipping channel wasn't complicated enough, the ships have to make a turn before they cross under the bridge, whether they're coming or going. So the new bridge was shifted about 300 meters to the east to provide more space between the bridge and the offset in the channel. Changing the bridge to be more perpendicular to the channel resulted in better maneuverability to ship captains. The new bridge crossing is almost 7 kilometers long. The span across the shipping channel is 106 meters, and the clearance over the channel was increased from 46 meters with the original bridges to 54 meters. The new bridge is also designed to handle a hurricane within 110 kilometers every other year. The new bridge design is 2 separate parallel roadways that merge into a single roadway on the main span. When you're driving across the water, on the lower portions of the bridge that are just above the water level, it would look like 2 separate parallel roadways. And then they merge into a single roadway as you go up and over the hump, and then back into 2 separate parallel roadways till you get back to land on the other side. Okay, now we're going to get into the construction of the new bridge. Even though the lower level, what is called the lower level approaches of the bridge, so those pieces of those sections of bridge that are just above the water surface are considered 2 separate parallel roadways, they are connected to each other by concrete struts. This link reinforces the spans together, so they work together like interconnected springs. I know it's weird to think about concrete and steel acting like a spring. To you and I, concrete and steel is a solid, non-compressible object. But every object has a breaking point, and there is some ability to absorb force depending on the composition of each material. In the event that the low-level approaches or the lower sections of the bridge were struck by a ship, the 2 spans would kind of work together to absorb that impact without any damage. That said, if the damage was such that the bridge was going to collapse, that interconnected concrete strut would fail before it took out both sections of bridge. So if the ship impact was so great that the bridge collapse was inevitable, only one side, the side that was impacted, would collapse and the other side would remain intact. The main span over the shipping channel is built as one structure. Remember, the roadways merge together as it crosses the main span. The main piers support 130-meter cable-stayed pylons or towers, which the cables are connected to the tower, and then those cables span and attach to the center of the two roadways. One thing that I found really interesting about the new bridge was that because it's so long, there's different soil compositions under each of the different piers. They modeled the foundation system, and the number of piles and the pile depths varied based on the soil conditions at each location. During construction, there was continuous communication between the design and field personnel. This reduced downtime when any errors occurred. The low-level approaches for the bridge started in 1983 and were constructed until 1986. The piles were driven into position with a template, and if some were out of place, they either added more piles or some were evaluated to be within tolerance. And they used rebar cages for the pile caps that were fabricated off-site, so that made the install on the bridge simpler and more economical. Following the piers, the beams and decks were installed. The decks were one continuous pour from expansion joint to expansion joint. The expansion joints are necessary to absorb movement, so they're gaps in the concrete deck, and they accommodate shrinkage and creepage effects and changes in temperature on reinforced concrete. When you're driving over a bridge, those little cracks that you see, the ones that would be perpendicular to the direction of travel, and they kind of make that clunk, 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 clunk sound, those in most cases are expansion joints. The new bridge hasn't been without its own set of problems, although nothing as catastrophic as the collapse. Although, while they may seem like problems, to me they appear like general maintenance items that come along with a superstructure in a humid, salty climate. There was significant corrosion of steel in the precast concrete columns for the high-level approaches over top of the channel. Luckily, the segments are hollow and workers were able to enter the superstructure in 2003 and 2004 to reinforce the corroded sections. There were also some paint touch-ups done in 1998 using a new environmentally safe paint that faded faster than expected and began to show paint discoloration in 2005-2006. A full repaint was done between 2006 and 2008, including repainting the bridge's 42 steel cables a consistent shade of yellow, and rehabilitating the lighting system at the summit of the bridge. In 2014, the Florida Department of Transportation noted low bridge clearance prevented larger vessels from using the Port of Tampa terminals. Most cruise ships were too large to pass underneath the bridge. The bridge was officially named the Bob Graham Sunshine Skyway Bridge after the former governor of Florida and then U.S. Senator who presided over the design and most of the construction. So there you have it, the Sunshine Skyway Bridge in Tampa, Florida. While the original bridge design wasn't directly responsible for the collapse, the failure led to significant design changes to the replacement bridge to prevent such a failure from happening again. While this is somewhat different from previous episodes, it's a really important story that demonstrates how failures impact future designs and how we can learn from each other and grow as an engineering community. Henry Petrosky said, "Failure is central to engineering. Every single calculation an engineer makes is a failure calculation. Successful engineering is all about understanding how things break and fail. The real trick is finding the failure point on paper or computer during design before anything is built. That's why engineers love Excel so much. You can play around with variables in the formula and compare multiple outcomes very quickly." For photos and sources from this week's episode, head to FAILUROLOGY.ca. On there, you'll find an image of the old and new bridges, the collapsed bridge, a map of the bridge in relation to the channel, and the concrete dolphins. If you're enjoying what you're hearing, please rate, review, and subscribe to FAILUROLOGY so more people can find it. If you want to chat with me, my Twitter handle is @FAILUROLOGY. You can email me at thefailurologypodcast@gmail.com, or you can connect with me on LinkedIn. Check out the show notes for links to all of these. Thanks everyone for listening, and tune in next week to hear about the Hindenburg Explosion. Before there were airplanes, there were Zeppelins. Did you know they traveled around the world? I don't know how I missed that part of the story until now, but more on that next week. Bye everyone. Talk soon.